Hi students, the second problem in Doppler effect. An observer moves away from a stationary source of sound with a velocity 1/5 of the velocity of sound in air. Find the percentage decrease in the apparent frequency, and it is given the velocity of sound in air is 320 meters per second. So we will understand the problem first. The stationary source of sound means what? The source is at rest. So the velocity of the source is equal to 0. Now the velocity of the observer. So the velocity of the observer has to be written first. Now we can see that he is moving away from the stationary source. Suppose if this is the source, okay, and it is at rest. Source is at rest, and here is the observer. So he is receding away along the positive x direction. He is moving away from the stationary source. Okay, therefore the direction of movement is along the positive x axis, and it is given as what? 1/5 of the velocity of sound. So this is the velocity of sound divided by 5. So what is the velocity of sound here? This is given as 320. So this is 320 divided by 5. So we will divide it in 30. 6 5s are 30 and 5 4s are 20. So velocity of the observer is now equal to 64 meters per second, because it is 1/5 of the velocity of sound. Okay, what next? So here the frequency, actual frequency is also not given. So we have to find the percentage decrease in the apparent frequency. Percentage decrease. So F difference, F dash divided by F into 100. We have to find out. This is the percentage decrease in the apparent frequency. Okay, now we will first write the general expression. Okay, so what is the general expression? Irrespective of the different cases, the apparent frequency F dash is equal to actual frequency into V. Now usually we write medium. Whenever medium is not mentioned, we need not write plus Vm, then again plus 0 and all. Directly we will write V minus Vo divided by V minus Vs. Because here when it is not mentioned means the medium is assumed to be at rest. So that Vm is equal to 0. So this is the expression. F dash is equal to F into V minus V naught divided by V minus Vs. So we will substitute now. This is equal to F multiplied by V. The velocity of sound in air is given as 320. So this is 320 minus velocity of the observer is 64. So this is 64 divided by Vs is 0, is it not? Here Vs is 0. So divided by V. This is what? 320 minus 0 is 320 only. So that F dash is now equal to F into 320 minus 64 will be what? 256 divided by 320. So this is now equal to F into 256. 256 is 32 into 8. This is 32 into 10. So that 32 can be cancelled, and this is 8 divided by 10 is equal to what? 0.8. Therefore the apparent frequency is 0.8 times the actual frequency. Now what is to be found? The percentage decrease in the frequency, F dash minus or F minus F dash by F. Therefore F minus F dash divided by F is equal to F minus 0.8. So this is F minus 0.8 into F, because the apparent frequency F dash is 0.8 times the actual frequency. So divided by F. So that this is equal to F into 1 minus 0.8 divided by F. So F get cancelled. 1 minus 0.8 is equal to what? 0.2. Therefore, percentage decrease in frequency. Percentage decrease in frequency is this factor F minus F dash. Okay. So F minus F dash by F multiplied by 100. So this is equal to 0.2 into 100%. That is equal to what? 20%. So the percentage decrease in the apparent frequency is what? 20%. Such problems are very important for solving the problems in the competitive exams. I hope you must have understood well. Fine.